Welcome to our session on working with Data and Entity Framework Core. Before we dive into adding and querying data, let's take a look at the data model we'll be working with. We're using a model for a simple e-commerce application. It includes four main entities: customer, order, order detail, and product. The customer entity holds personal information like name, address, phone number, and email. The order entity captures details about each order placed, such as when the order was placed, when it was fulfilled, and which customer placed the order. The order detail entity links each order to its specific products, including the quantity ordered. The product entity represents items available for purchase, with details like name and price. Each of these entities is connected through relationships, allowing us to track which customers placed which orders and what products were included in those orders. Now let's move on to the class definitions that represent this model in our EF Core application. Let's start with the product class. This class defines the structure of the product entity in our database. Here, the ID property is marked as the primary key. In EF Core, any property named ID or the class name and ID, for example, product ID, is automatically recognized as the primary key by convention. However, you can explicitly specify it using the key data annotation, which we've done here to ensure clarity. Next, we have the max length 250 annotation applied to the name property. This annotation restricts the maximum length of the name field to 250 characters, which will translate into a varchar 250 field in the database. This is crucial for ensuring that the database schema enforces the same constraints as your application. Finally, the column type name equals decimal 6,2 annotation is used on the price property. This annotation specifies the exact data type in the database. In this case, a decimal with 6 digits in total, including 2 decimal places. This ensures that EF Core creates the price field with the appropriate precision and scale in the underlying database. Next, we have the order class, which represents orders placed by customers. This class includes details such as when the order was placed and when it was fulfilled. It also establishes a relationship with the customer entity through the customer ID foreign key and the customer navigation property. Additionally, the details property is a collection of order detail entities, linking the order to its specific products. Now let's look at the order detail class, which links orders to the products they include. The order detail class contains properties for quantity, product ID, and order ID, each linking the detail to a specific product and order. The navigation properties order and product allow EF Core to manage these relationships and ensure that each order detail is correctly associated with an order and a product. Finally, we have the customer class, which represents the customers of our e-commerce application. This class holds customer details such as first name, last name, address, and phone. The orders property is a collection of order entities, establishing a one-to-many relationship between customer and order. This setup allows us to track all orders placed by a specific customer. Now that we have our entity classes defined, the next step is to create a migration. A migration in EF Core is a C# file that contains code to update the database schema to match the current state of your entity classes. To create a migration, we use the add migration command in the NuGet Package Manager console. This command will scaffold a new migration file based on the changes in your entities. This command generates a migration named initial create. The migration contains up and down methods. The up method includes the code to apply the changes to your database, such as creating tables and defining columns based on your entities. The down method contains the code to reverse these changes if you ever need to roll back the migration. EF Core inspects your entity classes and uses conventions, along with any data annotations and Fluent API configurations, to determine how to map your entities to the database. This includes creating tables for each entity, setting up relationships, and defining constraints such as primary keys and foreign keys. The generated C# code reflects these decisions and serves as a blueprint for updating the database schema. After creating a migration, the next step is to apply it to the database. We do this using the update database command in the NuGet Package Manager console. This command executes the code in the migration's up method and updates the database schema accordingly. When you run this command, EF Core connects to your database and applies the migration. It creates any new tables, alters existing tables, and sets up relationships between tables as defined in the migration. Essentially, it propagates the changes defined in your entity classes to the database. This process ensures that your database schema is always in sync with your application's data model. If you make further changes to your entities in the future, you can create additional migrations and apply them using the same commands, allowing your database schema to evolve alongside your codebase. Thanks for watching.